In this video, I will explain what is DFE, Design for Environment.
At the beginning of 1990, it was thus possible to have an overall vision of the effect of environmental issue on design activities extending to the most diverse areas. So you can see from 60 to 70, nothing happened, and from 70 it started till 1990, that is after 2 decades. So total 3 decades. It was possible to have an overall vision of the effect of environmental issue on the design activity. So if the design activities are changed, the environmental issues can be slightly modified. And here we are talking only from industrial point of view, because all products that we are using are manufactured in industry only. Now comes design for environment. So the first consideration of the technical aspect associated with the practice of a design action directed at reducing the environmental impact of product appeared in the first half of 1980, around 1983-85. The actual change in the design started here. In this way, in 1990s, a new approach. Now, I told you here, see, in 1990s, overall vision of this effect was started, and here you can see in 1990s, there were so many terms which were born, and the terms are design for environment, DFE, green design, environmental conscious design, eco design. All these terms were uh, generated from somewhere. All these terms were generated, and then the LCCA and the development for green environment and all that, the greenhouse effect and all those had been developed in this same time. So we'll see a little bit about this design for environment. We have 10 minutes, okay? So the first term. So out of this so many terms, we are discussing about this first term, design for environment, how it can help in sustainability. Some thoughts on the relation between technology and the environment were seen as the fundamental principle that can serve as the basis for the development of most effective methodologies for their complete integration. The methodologies must be wide-ranging and based on systematic statement. So when you are framing a methodology such that you are designing for environment, DFE, then some statements are to be there, which should be systematic. The approach must be multidisciplinary, that is, it must include technical, legal, economic, and political aspect. Okay, so when you are designing for this environment, when you are incorporating environment safety in the design process, you must think about technical aspect, the legal aspect, the economical. Legal aspect means what is unlawful. If the government is saying that your emission should be less than this, then it should be less than this. Okay, that it is that. That's why I told you about stages, Euro and this Bharat, the stage norms had come. Technology plays a key role in the solution of environmental problem. It is therefore necessary to encourage the evolution of process and product technologies oriented towards environment protection. It is therefore necessary to encourage the evolution of process. The process should be developed in such a way that it should be evolved in such a way that the technology should be evolved, technologies where in which or through which products are manufactured should be evolved in such a way that it is oriented towards the environmental protection. Okay. All the economic factors involved in the process of developing industrial products must assimilate a situation of environmental constraint as extended possible. जितना हो सकता है उतना environment के बारे में सोच के ही product को design करना है. Development policies and legislative pressures must encourage the development of programs of research and experimentation that support the innovations required by this change. Now comes design for environment. So the first consideration of the technical aspect associated with the practice of a design action directed at reducing the environmental impact of product appeared in the first half of 1980, around 1983-85. The actual change in the design started here. In this way, in 1990s, a new approach. Now, I told you here, see, in 1990s, overall vision of this effect was started, and here you can see In 1990s, there were so many terms which were born, and the terms are design for environment, DFE, green design, environmental conscious design, eco design. All these terms were generated, and then the LCCA and the development for green environment and all that, the greenhouse effect and all those had been developed in the same time. So we'll see a little bit about this design for environment. We have 10 minutes, okay? So the first term. So out of this so many terms, we are discussing about this first term, design for environment, how it can help in sustainability. Some thoughts on the relation between technology and the environment were seen as the fundamental principle that can serve as the basis for the development of most effective methodologies for their complete integration. The methodologies must be wide ranging and based on systematic statement. So when you are framing a methodology such that you are designing for environment, DFE, then some statements are to be there which should be systematic. The approach must be multidisciplinary, that is, it must include technical, legal, economic, and political aspect. Okay, so when you are designing for this environment, when you are incorporating environment safety in the design process, you must think about technical aspect, the legal aspect, the economical. Legal aspect means what is unlawful. If the government is saying that your emission should be less than this, then it should be less than this. Okay, that it is that. That's why I told you about stages, Euro and this Bharat, the stage norms had come. Technology plays a key role in the solution of environmental problem. It is therefore necessary to encourage the evolution of process and product technologies oriented towards environment protection. It is therefore necessary to encourage the evolution of process. The process should be developed in such a way that it should be evolved in such a way that the technology should be evolved, technologies where in which or through which products are manufactured should be evolved in such a way that it is oriented towards the environmental protection. Okay. All the economic factors involved in the process of developing industrial products must assimilate a situation of environmental constraint as extended possible. जितना हो सकता है उतना environment के बारे में सोच के ही product को design करना है. Development policies and legislative pressures must encourage the development of programs of research and experimentation that support the innovations required by this change. So there has to be some policies. The policies should be framed, and they must encourage innovations which are bind by this environment related activities. Now if I talk about additive manufacturing or 3D printing, I think all branch students understand what is 3D printing. So it is called as a green process. It is called as a green process because there is no much emission which is happening. So like that is an innovation of few years back. That was an innovation. Right now it's not that. It's not called as innovation, but earlier it was innovation. So there should be some support from the government or from the developing agencies, and they should make some policies such that these type of innovations are encouraged, which will prevent the environment. And then we can say that it is designed for the environment only. The implications of this principle in industrial practice require the direct involvement of the product design and development process as a direction of dissemination and integration of the new environmental need. So all these principles which we have seen, these are the various principles, and all these principles says that it should be there should be direct integration of these things, environment related things in the product. Design for environment originated precisely to play this strategic role. What is this DFE doing? It is playing this role of integrating the design related thing in the sorry, integrating the environment related thing in the design. Its definition was initially ambiguous, has evolved over the last decade. Earlier, the definition of DFE was ambiguous. People were not clear about what exactly the definition is. But then over the years, it was evolved, and the first presented in a reductive manner as a design approach. So the earlier definition was that it is a design approach directed at the reduction of industrial waste. See, understand the definition. DFE is a design approach which is directed at reduction of industrial waste. Whatever waste is coming, that should be reduced. And the optimization of the use of material, DFE subsequently acquired a more appropriate dimension. And the optimization of use of material. So it was designed for environment. And what was the first definition? It says that the industrial waste should be reduced and the use of material should be optimum. Further, it was considered as maintaining the necessary attention on the management of waste and resources. Okay, the next or few days was like it was considered as maintaining on use of waste and resources and integrating it in a systems vision, clearly inspired by the principle of industrial ecology. So it should be added as a part of the vision of the system, vision of the process, that it should be properly that proper attention should be given for the waste and resources. Then another definition is was put forward. I have not put the day year here and the people who or the agency who have provided a definition. I am just giving the definition. It says that a design process. What is DFE? A design process that must be considered for conserving and reusing the Earth's scarce resources. Understand now. It is a more clear definition, and where the vision of this DFE is more clear and it is focused on the environment. We'll read it again. A design process. DFE is a design process that must be considered for conserving and using the Earth's scarce resources, whatever scarce resources are available. So it's not talking about the solar energy. Solar energy is available in abundance, and we know that for thousands of years to come, it's not going to be diminished. It will be there. So it is not a scarce resource, but considering conserve the scarce resources, the resources which are available in limited in the earth, where energy and material consumption is optimized. At the same time, first thing that you are doing is conserving the earth's scarce resources. Another thing, energy and material consumption is optimized. Recycle the paper. If you are recycling the paper, then what you are doing, you are preventing the cutting of trees. Forest will not be cut because paper is made from forest, paper is made from tree. For paper, trees are cut. So if you are reusing or recycling the paper, that's why I gave you an example that day, that if you have used paper, instead of putting it in the dustbin, you can put it in the this for give it to the scrap dealer or rag picker or those raddiwalas, because it can be recycled. If you put it in the dustbin, it will just add to the heap of the garbage. So also there were new ways. Now plastic paper has also come. So energy and material consumption is optimized. Minimal waste is generated. Try to design the process in such a way that minimal process is generated. And the additive manufacturing which is used nowadays, the waste in the additive manufacturing is very less as compared to the conventional processes which were used in the industry, where material was removed. The waste is generated, minimal waste is generated, and output waste streams from one process can be used as the raw material of other. See, this is very important thing that is mentioned here in the DFE designation. Output waste from one process, can it be used as input to the another process? Can that output waste which is coming from the first process be used to make some new product, may be used to do something different? Like for example, after extracting oil out of the groundnuts, what is left, that can that be utilized for some different work? Okay, so that is a very important thing which is mentioned here, that output waste from one process can be used as the input for other.
I will quickly revise what I have explained till now.
Then we had seen that there are different approaches that had come. one of it design for environment. Then I think we had also discussed about this, the different methodologies, how it should be, then what is the role of technology and all those things. What finally DFE is? DFE is a design process that must be considered for conserving and reusing the Earth's scarce resources. That DFE, in addition to its specific primary objective and orientation towards the life cycle, the DFA is characterized by two aspects. The first aspect it is having a dual nature in the sense that takes into account the product as well as the processes. Product point of view and from process point of view. From both the point of view, the design should be based from both the point of view. And second, it says that the active action of intervention, that is whenever intervention has to be there, it should be based on the assumption of greater effectiveness of intervening early in the product development process. That is, it means that the whatever intervention has to be there in the product development process, that should be at the early phase of the design and should not come at the latter stage, because latter stage we had seen that in the latter stage, if the design changes are to be made, then it becomes very costly, and in some cases it becomes difficult to make the changes in the design. This topic, design for environment, is completed here. Then the next topic is implementation of design for environment. How do we implement the design by considering environmental factor or environmental aspect? So when the subject of environmental improvement is a product, whether the subject of environmental improvement is a product or process or each flow of resources that is part of a process or part of the product, DFA is implemented in design practice through three successive phases. So in order to implement DFA, there are three phases. Irrespective of whether the DFE, design for environment, is applicable or implemented for product, for process, or any small amount of process or product, part of the product, there are three stages. The first stages or phases, the first is breaking stage. What is this breaking? Breaking means it consists of identifying the target of the intervention, where you want to intervene. That is, whether you want to intervene in the product, you want to intervene in the process, or you want to intervene in the resource flow. Identifying possible alternatives and determining the depth of analysis. So first thing is to break down the activities and determine the depth of analysis. That is the first stage. In the second stage, it will just be data gathering or collection of data. Data gathering, which consists of acquiring and evaluating the most significant environmental data. Environmental data in the sense the data which is creating of effect on the environment. It is LCI and LCIA. What is LCI? Life cycle inventory, and LCIA is life cycle inventory analysis. So that is the tool which will be used in the second stage, that tool of LCI and LCI. Then in the third phase, it says that data translation, which consists of transforming the result from primary data analysis data into tool. So it is talking about translation of data, that is movement of data or switching over of data from preliminary analysis into tool. Preliminary analysis data means the data one which is in the form of in the page on the pages, that is which is done with the help of pen and paper, and that can be transformed into tools. So generally it is talking about the software tool, and this data will go into the software tool. In practice, the second and third phases are implemented using two instrument types or types of instrument. The first one is the LCA or LCIA and LCCA. These are the tools which we used for the second phase. The tool helping the analysis of life cycle, that is LCA, LCIA, LCCA, allowing the acquisition, elaboration, and interpretation of environmental data. And in the next step, for the next phase, for this phase we need to transfer the data. So tools aiding the design or redesign, like product and process design, design for use, design for end of life, design for X. So out of which we have already studied what is design for X in the second module. So these two phases are carried out by use of these two tools. These tools are based on a wide range of series of suggestions and guidelines for the designer that can be summarized as follows. So the first guideline, it says that reduce the use of material, use recycle and recyclable material, and reduce toxic or polluting material. It says that reduce the use of material. Instead of procuring new material, instead of purchasing new material, use the recycled material or use material which is recyclable. What will happen because of this? Because of this, the material or the fossil fuels which are available in the nature, that will not be consumed and it will be there for long period of time, maybe for the coming generation. That's why reducing the use of material, and by using recycled and recyclable material, and reducing toxic or polluting material. So try not to use such material which is creating hazardous gases in the, which is liberating such gases in the environment, or it is polluting the maybe water, maybe land or air. Try not to use such material. So this is first guideline. Okay. So what I am giving to you are the guidelines or suggestions. Why? So that two, sorry, these three phases, 1, 2, and 3 phases can be properly implemented, or DFE can be implemented. The second suggestion or guideline is maximizing the number of replaceable or replace recyclable component. So add such components in the product design which are replaceable or recyclable. Now recyclable, you have understood that it should be recycled and then again it can be used. What is replaceable here? Replaceable in the sense, if you are making an assembly of say 50 parts, the assembly of 50 parts. So break that assembly of 50 parts into, I'm just giving a number, break the assembly of 50 parts into 10 assemblies or 10 sub assemblies. Each assembly is of 5 parts, or break the assembly into 5 parts and each assembly will be of 10 parts. Then, if possible, break those 10 parts also in sub assemblies. So at the most, if you want to replace, you will not be replacing that entire part of the assembly of 50 products, 50 different products. You are just replacing maybe, if possible, only one, or if not possible, replacing only 3 to 4 parts. So instead of replacing this entire part which is not working, just break it into different parts, different sub assemblies, and then that only that portion, if it is not working, that can be replaced. So that will save the, because only that much portion is not working, the remaining portion of the assembly is working. So why should you replace this remaining portion which is working, and then you are consuming the resources that are available in the nature. So that's why it says that maximize the number of replaceable or recyclable components. Then the third guideline or suggestion is reducing emission and waste in the production process. Now, how this emission can be reduced? When you are designing a part, that time you should design it in such a way that there should not be emission. But then this is not possible. Obviously, there will be some or other emission. But then you design it. Can the design be modified in such a way that the emissions which are coming out of when the product is being operated, can it be reduced? Can it be reduced? And also the waste in production process, while the many part is manufactured, can the waste be minimized? Can it be minimum to a minimal level? Then increasing energy efficiency in phases of production and use. To design the product in such a way that the energy efficiency is increased in the phases of production and use. During production as well as use, the efficiency of the energy that is used. whether you are using mechanical energy, thermal energy, chemical energy, heat energy, water, use it efficiently. Now this also can be studied properly, and then you implement that in the design, like what way you should use the energy so that it should be utilized efficiently. And when we are saying efficient utilization of energy, we also mean that the energy is saved. If we are needing suppose 10 units of certain energy, try to do it in some 6 units or 5 units of energy, and that by that way we are saving either 4, we are saving the 4 or 5 units of energy, which can be used for different processes. And this way we are trying to consume less amount of resources and keep it in spare for the next generation. Increasing reliability and maintainability of the system. Now, if you are purchasing a product which is manufactured in China, we commonly call it as China product. Okay, so it is less costly, and we don't have a guarantee whether it will last even from the shop to our home. So there is no reliability in the product. If the reliability is not there, maybe some part of the product is not working, and because of that, the entire product has to be thrown. So if you are producing many products and just putting it in a dustbin, then definitely the resources utilized will be more. Is it not possible to produce reliable product, the product which will last for few hours or few thousand hours depending on what the product is, so that the number of product produced will be less. The increased reliability and maintainability of the system. Facilitating the exploitation of materials and recovery of resources by planning the disassembly of components. Should facilitate the exploitation of materials and recovery of resource of planning by disassembly of components. The components which are manufactured should be able to disassemble. You should be able to disassemble, and you should be able to exploit the material which is used in those components, and we should be able to recover those material from the assembly, and by doing some modifications, whatever it is depending on the material, we should be able to put it again in the next product or new product. So that will allow use of the resources which are available in the nature to a less extent. Further, it talks about extending the product's useful life. Now, do you think that the products manufactured nowadays have a long life? No, product don't have long life, because if now the trend is like, if you manufacture a product which does not fail, then who will purchase new product? So the products are manufactured in such a way that its life is very less, so that the new design when it is coming in the market, that should be able, people should have requirement, so that they should purchase a new product. Just to give an example, we when we get mobile update, okay, software update on the mobile, like I will not name any company, but then there are companies who are providing updates for the software for the mobile. After a few updates, their update is such that the mobile performance of the mobile is slowed down. It becomes slow. So that is because of the update, and why that is because the new product should be purchased by the customer, because the product is excellent. It has been running good for so many years. Now because of the update, it has happened. Same is the example with antivirus. The companies who are producing antivirus, maybe they are producing virus, unless and until there is virus, why antivirus will work? Why antivirus will be needed? So this is what has to be done, but it is not done everywhere. We are seeing that even the quality of the road that are manufactured, the quality of food that is manufactured, everywhere we are seeing that the product's life is not long, it is not extended, but theoretically it is saying that extend the product's useful life, so that number of products manufactured will be less. You think from the manufacturer's point of view, if the number of products manufactured will be less, then what will happen? The profit will be reduced. And if the profit is reduced, they will not accept it. Then planning strategies for the recovery of resources at end of life, facilitating reuse, remanufacturing and recycling and reducing waste. I give you an example of cold drink, which can be uh, sold in a glass bottle. Now, if it is sold in glass bottle, this glass bottles can be reused. Now, it is if it is sold in plastic bottle or Tetra Pak, then that will go as a waste. And since it will go as a waste, where are we recycling it? Recycling, maybe it is happening recycling, but if it is used in a glass bottle, uh, or if it is sold in a glass bottle, the amount of emission will definitely be less, and every time we don't have to make new plastic bottle. Even few years back, I don't know if you anyone of you know, but even in few years back, this milk was also sold in glass bottles. Glass मतलब कांच का bottle. I don't see it right now, but I have seen it during my childhood days that milk was sold in glass bottle. There is only one issue with the glass, it may break, that's it. Otherwise, it can be reused. Only the cost incurred is of transporting it back to the company and the cleaning of the glass bottle. That's it. So planning strategies for so some strategies should be planned for recovery of resources at the end of life, facilitating reuse. Now we have a pen that are available in the market, which we call as use and throw pen. The pen which can it be recycled? No, it is. That pen which is not working will be thrown in the dustbin, and from dustbin it will go to the garbage heap. How do can we guarantee that out of 100 pens produced, all 100 goes to the recycling bin? No, maybe only 5% of that goes to the recycling bin. Others are going to the garbage heap, and that is so. Earlier there were pens where we used to refill it. That the refill of the pen was replaced, and another refill was placed in the pen. We also had ink pen. I don't know how many of you have seen there was ink pen, but ink was used, and the pen used to last for long. It's not like we use it nowadays. So facilitating reuse, where is it happening? It's not happening. I cannot quote you examples where they are facilitating the reuse, remanufacturing and recycling and reducing waste. This is what is there in the in the journal papers. It's there in the guideline, in the procedures. That's it. It's not followed nowadays. Maybe if you are aware of any example which is contradicting my statement, you can unmute your mic and tell it to me that products are manufactured right now for the recovery of resources at the end of life. It is facilitating the reuse, it is remanufacturing and recycling, and the waste is reduced. So if all those things happen, the waste will be reduced, and we are interested in two things. One is reducing waste, and at the same time limited use of resources. If the waste is reduced, the limit use of resources will be limited, and we will be able to save it for the next generation. Okay, continuing with it, controlling and limiting the economic cost incurred by design interventions aimed at improving the environmental performance of the product. Controlling and limiting the economic cost incurred by design intervention. So whenever you are designing a product and there are a lot of inputs in the designing, that time we should try to control and limit the economic cost. Okay, so the cost of the product should be as less as possible. Try to use alternate materials, alternate product, or try to procure it from a location which is close to your industry. If you are procuring it, if you are procuring some different material which is not available in your vicinity, not available in the area from which you are, which you are, the geographical area where you are in, then the cost required will be more, because transportation cost will also be added to it. So by some or other way, try to control and limit the economic cost or the cost of the product during the design interventions. Respecting current legal constraints and evaluating future regulations. So I was telling that day that the Bharat stage 4 5 norms which have come. Okay, so manufacturer should respect the legal constraint that the emissions should not be more than that. We should not use uh, kerosene in the vehicle, which we have seen at different places. So they are using kerosene in the vehicle. That is, they are uh, not following the constraint. But then we are not talking from the user point of view. We are talking here from the manufacturer point of view. So what user will do? User will continue to use kerosene. What manufacturer can do? Manufacturer can manufacture an engine such that if kerosene is put in the engine will not work. It will not start. So there are some ways which can be used during the design of the project, design of the product. That is what it is saying, respecting the current legal constraints and evaluating the future regulations. Evaluating what can be the future regulation, just find it out and manufacture as per the requirement of the future. Now, these are the guidelines, and by applying these guidelines in relation to the main phases of the product life cycle, it is possible to obtain useful information and to explore the whole set of opportunities for an eco-efficient intervention in the product design and development process. Just to give an example, which I have recalled now, like this Ganpati and Durga Devi idols, which are used in Maharashtra mostly, they are made up of. In fact, they should have been made of by of soil, but they are not made up of soil. They are made by some different materials like plaster of Paris or maybe some different material. So when they are made of this material, what is happening? If it is had it been made up of soil, it would have dissolved in water. But these are not dissolved in water. So are they following these guidelines which are given? No, they are not following. So I can uh, give examples only where the guidelines are violated, because I don't see examples where the guidelines are followed. If they are followed properly, then the eco-efficient product will be designed. So the intervention in the design should be eco-efficient. Then to continue with this was the implementation of design for environment. And then the next topic is environmental strategies for the life cycle approach. What are the environmental strategies for the life cycle of a product?